Welcome back to Math 103. This is video number 12 on growth and finance. As we study more frequent compounding, please get used to interest rates which are themselves less than 1%. They will be very common when we break down annual interest rates, such as 4.5%, into monthly interest rates, such as 0.375%. Okay? And we'll also look at weekly interest rates and daily interest rates. Another caution, and this is a very common error, when the bank pays 4.5% annual interest compounded monthly, it most certainly does not pay you 4.5% every month. It does not make your account grow by 4.5% every month. If it did, that would mean that the bank was giving you a year's worth of interest every month. That can't be. No bank is that generous. Instead, what's happening is that the bank gives you a month's worth of interest every month. That's why that 4.5% annual rate has to be broken down into a monthly rate. We were looking at an example of investing $3,000 into an account that has an APR of 4.5%, but compounded monthly. Banks typically quote interest rates in annual terms, and then, somewhere in the fine print, you will find out something about how frequently the compounding occurs. That monthly compounding, we can investigate further and ask, well, what's the effect of many months of monthly compounding? The future value of this account after 1 month equals the initial amount, $3,000 invested, times 1 month's worth of growth, times the 1 month growth factor. Great, that's $3,011.25. What about after 2 months? Well, this follows a thought process that by now is very familiar to us. $3,000 experiences a month's growth and then another month's growth. So that's the same thing as $3,000 is multiplied by the 2-month growth factor, and it grows to $3,022.54. We can ask, well, what about after 6 months? Same thought process. That $3,000 is multiplied by the monthly growth factor on 6 separate occasions. Every month, for 6 months, the bank is multiplying your account balance, whatever it is, by 1.00375. So there are 6 successive multiplications by 1.00375. Okay, that has the same overall effect as 1 multiplication by 1.02271. In other words, this number here is the 6-month growth factor. And so your $3,000 will grow to $3,068.14. Before going on to the next video, answer the following questions, which contain some important ideas for this subject. First, find the future value of the account, the one that starts off worth $3,000, after 1 year, 1 full year of compounding this APR of 4.5% monthly. Once you've found out the effect of a full year of this monthly compounding, how does earning 4.5% annual interest compounded monthly for an entire year, the thing you just computed, how does that compare with earning 4.5% annual interest compounded just once? In other words, compare this new idea of a whole year worth of monthly compounding to what we were doing before, when there was just 1 growth at the end of the year. Finally, once you've done that, find the future value of the account after 2 years of compounding monthly. Right, so first, this is 1 year of compounding monthly. Find the effect of 2 years of compounding monthly.